This video is for ELEC 2132. This is a bonus lecture, number 1, where I'm going to be talking about dependent sources in LTSpice. The first type of dependent source that I'm going to go over how to simulate is a voltage-dependent voltage source. So I've constructed a sample circuit here. I have a 9-volt source here. I have a 2.2 kilo ohm resistor right here. Vx is our voltage that the dependent source is dependent on. A 4.7 kilo ohm resistor here, 3.3 kilo ohm resistor here, and then the voltage dependent voltage source right here, which is minus 2 Vx. All right, so let's move into LTSpice. So I've got the general circuit here. I have the voltage source and the 3 resistors already placed in the source with the ground down here. Now I'm going to place the voltage dependent voltage source, which is the component named E. It's kind of a random name. I'm not sure exactly why it's called E in Spice, but you know, that's what we have to work with. Okay, so E is a voltage source with 2 terminals that are the voltage difference that it multiplies. So we can either connect these directly to the voltage that the source is dependent on, or we can label the nodes in the circuit. I'm going to choose to label the nodes. So it was voltage A here, so I will label those as the same node using the label net tool up here. It's a little signpost with an A on it. I can call these nets whatever I want. I usually just use A, B, C, D, things like that. And B is over here. Now, in order to put in the multiplier, I right-click and I change the value E to be my value of interest, which was minus 2. So now I'm going to simulate. For all of these simulations, I'm going to do a DC operating point, and I'm going to be concerned with the 2 unknown voltages here and here. That's from an old simulation. I have to rerun the simulation in order to get the new results. So these 2 voltages are not very different, 6.728 volts and 6.544 volts. All right, so that's the voltage-dependent voltage source. Now let's look at a current-dependent voltage source. I have the exact same circuit. However, I'm now looking at a current somewhere in the circuit, in this case I sub X flowing through the 2.2 kilo ohm resistor, and my voltage source is now 2500 times that current. All right, so let's move back into LTSpice. All right, so one of the things that we need to do in LTSpice is make sure that the current that we're measuring is actually the current that we're interested in and not the negative version of the current that we're interested in. It's a little bit difficult to tell. We can see right here if I hover over R1, in the lower left it says that the current is 1.487 milliamps, but I don't know which direction that's flowing. I don't know if that's left to right or right to left. One of the things that you need to be careful about when using current-dependent sources is making sure that the current that your source is dependent on is flowing in the direction that you think it is. LTSpice designates currents through components based on their geometric orientation, and it's hard to tell just based on the way that they look right now whether it's flowing left to right through R1 or right to left through R1. There's a different type of simulation that you can use in order to tell. So we're going to run that simulation first. And so I'll go to Simulate, Edit Simulation command, click on Transient, say Stop Time 1M. This isn't really important. I'm just saying I'm going to stop the transient simulation at 1 millisecond. drop that into the circuit, you can see that now the .op changed to a semicolon op, meaning this is a comment now. And when I run that simulation, now when I hover over the components, I see my mouse change to a little symbol with an arrow. This arrow is flowing left to right through R1, and so the current in LTSpice is designated in the direction that I want. I can hover over really any of these components and see which way LTSpice thinks the current is flowing. So if the current happened to have been flowing in the wrong direction, what I can do is snip this component out of the circuit, select it and rotate it, then reattach it into the circuit. When I re-simulate, I now see that my arrow flows right to left through that component. However, I really want left to right, so I'm going to reverse that again to get it in the correct orientation. Now, I know that the current is flowing left to right, so I can get rid of this transient simulation and go back to .op for the DC operating point simulation. Okay, so now let's change this to a current-dependent voltage source. We can cut out this component and add in a current-dependent voltage source, which is going to be the element BV, behavioral voltage source. So I'm going to right-click on this element and enter in the function 2500 times I parentheses R1. That's 2500 times the current through R1. We've already configured it and seen using the transient simulation that the current flows in the correct direction. And let's simulate. So now I get new voltages, 6.077 volts roughly, and 4.459 volts. All right, now let's talk about a current-dependent current source. This is the same circuit again. I'm going to be using the same current, I sub x, except now I'm using a current-dependent current source with value negative 0.3 times I sub x. So let's go back to LTSpice and change that component out. Okay, so I cut out the behavioral voltage source and I have to add in BI, which is the behavioral current source. By default, it points down, so I'm going to rotate it to point upwards. And I change the function to be negative 0.3 times I parentheses R1. That's the current through R1, which we configured to flow left to right. Now simulate, and I get my voltages out, 5.993 volts and 4.190 volts. Okay, we have one more dependent source left to configure. All right, the last dependent source that we have to worry about is a voltage-dependent current source. So now I'm going to write a new voltage in this circuit. V sub y is across the 4.7 kilo ohm resistor, and the current source that's dependent on it is minus Vy over 1000. So let's go back to LTSpice and configure that. Okay, so I'm going to cut out the behavioral current source, and I'm going to add in element G, which is a voltage-dependent current source. So the two terminals here are what the multiplier will create a multiple of to generate a current. So I can either label the nodes or I can connect these with wires. Because I'm concerned with the difference between this node and ground, I'll just connect the negative terminal directly to ground rather than labeling it. And then I will connect the positive terminal to node A. Now for the multiplier G, I label this minus 0.001 for minus 1 over 1000, and rerun my simulation. And my voltages are 2.726 volts and minus 6.270 volts. So that's all 4 dependent sources in LTSpice and how you can use them. Obviously, the current dependent sources are a little more tricky because you have to worry about the direction of the current. So you have to probably run a transient simulation briefly just so that you can see which way the arrow is going in the LTSpice. And you have to enter in a function rather than just entering in a multiplier.